Good afternoon, class. In today's video, what I'd like to do is to go over energy. Now, in this video, I'm not going to go into detail too much on all the different types of energy or, all of the different ways in which we can utilize these energies because there are many. This is more of a cursory introduction to it where I go over all of the different types, a little bit into the equations that govern them, and then that's pretty much it. If I need to do more in terms of each specific type of energy, I'll have separate videos on that later on. So let's go over this as we summarize all the different types of energy that we deal with in physics. There are two main types, and then there are other ones as well. There are many names that we can give them, but in general, the two main ones are kinetic energy, which is why we leave it as Ke, as that's what we would label it, and potential energy, Pe. Now, I have to have a little bit of a clarification with this potential energy. This can have a lot of other names that are attached beforehand. For example, you could say things like gravitational potential energy, chemical potential energy, spring potential energy, and those I will go over right over here. So I'll get to that in a little bit. So for now, let's talk about kinetic energy, or the energy of motion. It is governed by the equation kinetic energy equals 1/2 mv squared. So the kinetic energy will be 1/2 the mass times the velocity squared. If you want a more advanced version of how I got this equation, you can see my more advanced videos that I'll be making at a later time. Now let's move on to potential energy, which comes out to potential energy is equal to mgh. This is the equation that we'll be using at the most basic level of physics. In general, this is the easiest one to measure. This is not the one that is a general equation for all potential energies. This is more specifically for gravitational potential energy. So, but the reason why I use this one instead of others, one, because in general this is what you're going to be using for homework, and two, the reason I use this one is because it's much easier to quantify than things like chemical potential energy or thermal energy. Those kind of things they're quantifiable, but the equations that are necessary to understand them are very complex, and they require quite a bit more in-depth study to fully comprehend them. And I'll even admit, even I don't quite understand all of them, especially thermal energy, because that requires graduate work in terms of, you need at least a master's or a PhD in physics to understand some of these thermal equations. And the reason is mostly because they get especially when you get into the real world, or when you get into real life, instead of these idealized scenarios like these equations are showing, you have to take into account numerical solutions to the problems. What that means is that there's no exact number that's going to answer the question. You will get a range of numbers that can potentially answer the question, and the way you solve real world problems is in the same way. You would get an idea of what the answer is, and then you develop what we call a tolerance for it. So you might say, oh, the answer is between 1 and 2, but we don't know exactly where between 1 and 2. So that's how we solve most problems in like real life problems. So that's why a lot of times what you'll see with engineers is that they will always do things like when they make the speed limit, for example, of a road, they always design it so that you can travel on that road safely at about twice the speed that they actually post on there. So, but of course the law does not allow you to, so don't speed, even though, you can just go on the freeway anytime and you'll see people speeding, right? But the thing is, engineers have designed the roads to be able to handle safely those kinds of speeds, even though because they know people will speed on those roads. It's unavoidable given human nature. So we've got potential energy. This is the one we're going to be using in class mostly. So there we go. And of course, the way I like to think about potential energy is that it's energy to be utilized later. They're not really energy now. So for example, and one way to connect both of these, especially the gravitational potential energy, is if I take a ball and I drop it off of a cliff, its motion as it's falling is kinetic energy. Now, the fact that I had it, a certain height above the cliff or something like that before I dropped it, meant that there was potential energy, gravitational potential energy right here. Then when I dropped it, it gained kinetic energy. And then when I caught it, I again stopped the kinetic energy, but that translates into a new potential energy. That's kind of how, so there's an interplay between these two. And in fact, I'll do another video later on where I talk about how that interplay actually comes together and how it can be utilized in either, in some very mild circumstances to some very extreme circumstances. And by that I mean black holes. So, the mild circumstances being these two equations put it together give you, allow you to go into orbit and be able to orbit the Earth like the International Space Station, and the extreme case is a black hole, just to kind of give you a preview of what we're talking about. The other one that I wanted to go over today was this other type of energy, which is thermal energy. Now, this one is broken up into two types, and I do want to stress from the beginning that while these are going to be covered, these can be covered, I put them in red because they are on the more enrichment side. We may get to them during the course of the year, we may not, and that's okay. It's one of those enrichment topics, but I thought it'd be worth at least showing you so that if you're ever interested in continuing in your studies, you've at least seen these types of equations. So thermal energy has two types. One is heat, which is given by the equation Q equals mc delta T. And if you want a little bit more of an in-depth an in-depth video on how to deal with these thermal energies, even these equations, I will make those at a later time. The other one, and this is the one that's, I have to admit, this one is a little bit tougher to really understand and really grasp, and that is this concept of internal energy. What it really is referring to is the kinetic energy of all the atoms in a container, in a system that has thermal properties to it. All the motion of all the atoms summed together gives you the internal energy. This is not necessarily very easy to comprehend, mostly because it starts to deal with groups and how groups of atoms interact with each other, and those interactions aren't necessarily going to have the same effect that they will instead of dealing with regular atoms, or regular particles, I should say. For example, dropping a ball off of a cliff, there's a very easy understood method of how that interplay goes along using kinetic and potential energy. Whereas with thermal energy, it's almost like having a trillion balls inside of a container hitting each other, and if you try to understand it the same way that we did with these equations, you would essentially be trying to track the path of one of these tiny little balls inside of a container that contains a trillion of them. So, which is mathematically possible, but it is essentially an impossible task, especially for our human minds to try to really comprehend at that level. In fact, we don't even have technology that would be able to track something to the degree that most physicists would like, which is actually like basically having a camera track the motion of something as it's moving. So we don't have quite that. We don't have that kind of level of technology. So that's why we use this internal energy to speak of the group behavior of these types of molecules. Again, if you are thinking, wow, that's very complex, I do have a whole video on thermodynamics if you do wish to continue to study that, and if you wish for me to go into a little bit more detail of that. But I didn't want to do that in this video. This video I wanted to mostly focus on the main types of energy, because those are the ones that we're going to be dealing with in this class, at this level of physics. So that concludes my video on energy, at least in the terms of a very cursory summary view of it. So next time I'm going to make a video on maybe on the different types of energy and maybe some examples on how to deal with those kinds of problems. So that concludes this video. Good luck in your studies, and may the force be with you.